Hi everyone. Okay, I'm not sure if there's going to be an introduction or not, but I'm going to go ahead and start sharing my screen. All right, please let me know if and when you can see it. All right, there we go. Sorry. Okay, I believe everyone can see my screen. I'm going to go ahead and get started. Please feel free to jump in, Jamie, if you can't hear me or can't see me or something, and I'll restart or step back a slide or two. So thanks so much to Chainlink for having me. We're going to go ahead and get started. My name is Gabriel Cardona. I'm developer evangelist at Ava Labs, and today's presentation is called Subnets and Virtual Machines, a network of networks. We're going to talk about who we are at Ava Labs and what we've been building over the last couple of years, some highlights from our amazing ecosystem, which has emerged since we went live with our main net last August, around 14 months or so. And lastly, we're going to dig into a couple of the unique features and attributes of the Avalanche network, which specifically are subnets and virtual machines, hence the name of the presentation. So to get started, who is Ava Labs? So we are a world-class team of experts in the fields of computer science, economics, law, and finance. Our offices are located in New York City and Miami, but we have team members all over the world. I'm personally located in the San Francisco Bay Area, though today I'm actually coming to you from beautiful Lisbon, Portugal, where I have been for the last week attending Lisbon Blockchain Week. We set up something called Avalanche House, which ended up being an amazing venue for people to come and connect with our team. And we had presentations each day and connect with our biz dev and marketing and engineering team. It was 100% a success. So I'm still here today. I fly out back to San Francisco early tomorrow morning. So as a team, we are passionate individuals with a vision to create a frictionless world by redefining the way that people build and use financial applications. And the Ava Labs team has collective experience from leading Fortune 500 finance and tech companies through to high growth blockchain companies. And the logos you see here are just a handful of some of the teams that the Ava Labs team members have worked with prior to working at Ava Labs. Uh, Myself, I've been in the blockchain space for several years now. And out of all the teams that I've been on, I really genuinely believe that the Ava Labs team is the highest quality, starting all the way at our C-suite, which you see here, and then just going down our entire org chart. We have an absolute team of A quadruple plus players, and it's truly an honor to work with these ladies and gentlemen each day. Real quick, just to drill down on our C-suite a bit, our CEO is Emin Gun Sarir, who has been a professor at Cornell for over 20 years. And he was actually the creator of one of the very first virtual currencies for peer-to-peer systems, which was called Karma, way back in 2003. So, 5 or 6 years before Satoshi released Bitcoin, Goon, I should say, was already solving these problems and created a peer-to-peer virtual currency system. So that's kind of interesting. Our president is John Wu. John attended Harvard and Cornell and was previously co-founder of Sego or Sureway Capital. Our COO is Kevin Seknicki. Kevin is a PhD from Cornell and was previously at Microsoft and NASA. And then lastly, our chief protocol officer is Ted Yin. Ted is also a PhD from Cornell. He recently got his PhD, and he was also the creator of Hot Stuff. Hot Stuff is the classical consensus protocol behind Facebook's Libra, or they rebranded it DM Network. And so this is our C-suite, and as I mentioned, all the way down the org chart, there's just an absolute block stars, ladies and gentlemen, and it's an honor to work with them each day. Who am I? So as I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Ava Labs. I help maintain Avalanche JS, which is our TypeScript and JavaScript library. If you've worked in our ecosystem, you might potentially be using it. In addition to Avalanche JS, I also help maintain Avalanche. So Avalanche is our local test and development network. And then I also go around to conferences and conventions and meetups and hackathons, and I give presentations like today, hoping to inspire people to build amazing applications on the Avalanche network. And so I I personally believe that there is no more valuable resource on the entire planet at this exact moment than a competent, hardworking, and creative engineer. And I really feel that way because, as I see it, we are at a unique time in the evolution of our species where we really need to solve problems at scale and at velocity. And fortunately for us, there have been so many radical breakthroughs in computer science over the last, let's say, 150 years, going all the way back to Ada Lovelace and Charles Babbage until now. So, as I mentioned, we're fortunate that we have a tool set which is unlike any time in all of human history. So now what we need is hardworking and competent and creative people to really, step forward and build the systems that solve the problems. So, in my mind, there's never been a better time to have an amazing idea, find a like minded group of people, raise capital, and then change the world in a big way. And hopefully, I can inspire you to build your game changing idea on the Avalanche network. And then also, of course, I should mention that we are hiring. So if you're in the fields of computer science, economics, law, and/or finance, and anything I talk about today excites you in any way, please feel free to reach out to me personally. My contacts will be on the very last slide, or check out avalabs.org/careers and see the roles we're hiring for. We're hiring across the board for biz dev, engineering, marketing, operations, and product. Okay, so that's out of the way. Let's dig into this a little bit. Oh, that was who I am. Okay, so what is Avalanche? Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second with near instant finality. And we do that using a protocol which is completely green and quiescent. And we've paired this high throughput, fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. We accomplish this through this notion of subnets or subnetworks. And subnets allow anyone anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. And that's something we're going to dig into a little bit at the end of at the last part of the presentation. So the way to visualize Avalanche is a network of networks or a platform of platforms where we envision thousands and thousands of these public and private subnetworks all emerging into what we are calling the Internet of Finance. And so I wanted to give a brief history on the evolution of the blockchain revolution. I suspect that anybody watching this not going to be totally new to them. It's possible you've heard me give this part of the presentation before. I usually start my presentations with this little bit, or you might know this already if you've been working in the industry. The reason I repeat myself is simply that I have found that sometimes to really appreciate where you're going, it helps to appreciate where you come from. So I kind of want to step through why I want to step to Avalanche so we can get an appreciation of why we think it's such a leap forward in blockchain technology. So blockchain 1.0 was, of course, Bitcoin. In the beginning was Bitcoin, and the Bitcoin was good, right? So Bitcoin proved to the world there was the need for a robust and decentralized payment network. And it started its life out as, peer-to-peer electronic cash. But for better or worse, that's not ultimately what it evolved into. Ultimately, today, it's more marketed as digital gold. And there was a long time where I myself was super attached to the vision of peer-to-peer cash, and I wasn't totally happy with where Bitcoin ended up. But I've matured a lot over the last decade, of course, and my viewpoints have changed. And now I realize and I appreciate that Bitcoin has grown into a hedge against inflation for the mom and pop investor. And the reason I think that's important is because, in one way, inflation is theft. It's not like taxation, where at least you can say, well, my taxes go to fund the things that we all find useful in common, like the infrastructure which powers our world. With inflation, it's simply, each year your purchasing power decreases. And 1 out of every $5, so 20% of all of the US dollars that have ever been printed in the entire history of the United States were printed in the year 2020. And so, the purchasing power of every single person who's hearing me now, the purchasing power of their USD, their dollars, has decreased 15 or 20% in the last year. And I know I certainly feel it living in the San Francisco Bay Area. Everything around me just is more expensive this year. And that's because of inflation, right? There's so many dollars being printed, the purchasing power is simply going down. And so, this is potentially the beginning of what hyperinflation looks like. And if you don't think hyperinflation could ever happen or it could never happen to your country or the US dollar, I just say check out, Zimbabwe and Greece and Venezuela and Argentina, etc. There's been many, many examples of this. And so Bitcoin and other cryptocurrencies, obviously AVAX is one of those, allow you to simply opt out of inflation, which I think is so, so, so incredibly powerful. And so I just say, consider that. Trust me, your kids and the next generation will thank you for that. So, as great as Bitcoin was, obviously it has downsides, or we wouldn't be talking about blockchain 2 and blockchain 3 technology. And so, namely, Bitcoin is slow. It only does a handful of transactions per second. It doesn't have fast finality. It takes about an hour, 60 minutes, 6 blocks, where you can feel confident that your transaction won't be reorged out from under you. It's not lightweight and green. I think we all know about the meme that Bitcoin BTC burns more energy each day than some nation states. Although I will say, in my opinion, that's a short-term problem. We know that every single hour, enough energy falls on the planet in the form of sunlight to meet 100% of our needs for a full year. And that's fossil fuels, renewable energy, and nuclear energy. That's every single hour. So, really, the problem is that we need to harvest it, store it, and transport it. And obviously, there's plenty of people working on this problem today. That's why we see solar adoption going crazy and the price is dropping like crazy. And so I think we're probably within our lifetimes where we get most of our energy in a renewable way. So I'm not convinced that Bitcoin burning a bunch of energy is a long-term problem, but it's certainly a short-term problem. Um, Bitcoin doesn't really have great smart contracts. It does have a scripting language. It's called Script, kind of unimaginatively. But if you've ever worked with it, it's very cumbersome and it's very archaic. It doesn't feel modern. If you're used to a modern software workflow, when you work with Script, it does not feel modern. And then lastly, Bitcoin doesn't really have tokens, advanced tokens. It does have the ability to write 80 bytes of arbitrary data to the blockchain using the up return opcode. And then you can create wallets which can actually tease out that encoded data and decode it. And then within that, you can have asset issuance and movement commands. But again, it's very cumbersome and they're not miner validated. So it leaves a lot to be desired. So to sort of wrap up the Bitcoin chapter, Bitcoin really had a radical impact on many, many people's lives, certainly myself included. And so I always just like to express gratitude to Satoshi. My wish, if I could wish something for Satoshi, is that he or she or they or it, whatever Satoshi was, I hope that they're really out there living their best life. I hope that Satoshi is happy and healthy and working on the next generation of amazing technology. But as I mentioned, as amazing as Bitcoin was, it left a lot to be desired. So that's why we have blockchain 2.0, which is Ethereum. Ethereum is a decentralized app which enables developers to launch their own decentralized app on the top of it in the form of a smart contract. And prior to Ethereum, if you wanted to launch your own dApp, then you had to launch your own network, basically, right? You had to roll your own. And so this led to a very bespoke environment where few projects were able to reach the network effects required to tip and go mainstream. And so by enabling developers to launch on top of Ethereum, it enabled a huge network effect. And it also led to a huge wave of innovation around tokenomics, initial coin offerings, non-fungible tokens, decentralized finance, yield farming, prediction markets, distributed autonomous organizations, and so much more. The list goes on and on. So I'm still a big fan of Ethereum. I'm a big fan of Vitalik and his whole team. I perceive Vitalik as really being one of the great thinkers of our particular generation. He's still a young man in my view, and I imagine that his best days are still ahead of him. So I'm a big fan of Vitalik and Ethereum. But we consider Avalanche to be blockchain 3.0 technology. And so, similar to blockchain 1.0 and blockchain 2.0, there are a handful of new paradigms which we're introducing, which I'm going to briefly cover now. And then at the last part of the presentation, we'll dig into virtual machines and subnets. But the first paradigm shift is Avalanche consensus. The next is Avalanche is a network of networks. We also have virtual machines and we have subnets. So let's dig in a little bit and see what those are. So Avalanche consensus. What is consensus? You hear this all the time if you work in the blockchain space. What is it actually? Consensus is simply the process by which you get a group of independent validators to come into agreement. So it's really that simple. How do you get a bunch of different people to come into agreement on something? That's what consensus is. And it's a very, very rich field of computer science. It goes back at least 40 years. And there have been three major paradigms in consensus: classical consensus, Nakamoto consensus, and now Avalanche consensus. So, as I mentioned, classical consensus goes back to the 70s and 80s. And it has extremely high throughput and fast finality, and it's very, very green, but it's not scalable, it's not robust, it's definitely not decentralized, and it performs very poorly in adversarial conditions. In 2008, 2009, when Satoshi released Bitcoin, even though it doesn't say the word consensus anywhere in the white paper, academics and computer scientists were able to parse it and understand that there was a new paradigm here. It came to be known as Nakamoto consensus. And Nakamoto consensus is very scalable, it's very robust, and it's highly decentralized. But again, it doesn't have low latency. It doesn't have, it takes an hour for your transaction to settle. It doesn't have high throughput, as I mentioned, just a handful of transactions per second. It's not lightweight or green. We talked about it burning more energy than some nation states. And it performs okay in adversarial conditions, up to the famous 51%. In 2018, a pseudonymous group known as Team Rocket launched a white paper on the Interplanetary File System, the IPFS, introducing a new paradigm and consensus known as Avalanche consensus. And Avalanche consensus really is the perfect storm of features from classical consensus and Nakamoto consensus. So it's very scalable and robust. Today, I believe we have 1,096 full block and vertices producing validators. That's today. So it's very scalable and robust. It's highly decentralized. It has very low latency and high throughput. We get about 4,500 transactions per second and sub-second finality. So in less than 1 second, your transaction will be immutable and irreversible. If you compare this against Nakamoto consensus, there is no such thing as a reorg attack on Avalanche. That's not a thing that even exists. When your transaction settles, it is immutable and irreversible. Avalanche consensus is very lightweight and quiescent. You can run it on a Macintosh, on a PC, on a VPS droplet on the cloud, on an Internet of Things device. It's very, very lightweight, and it's parameterizable and performs very well in adversarial conditions. And we have this great demo. Sometimes it works in presentations, sometimes it does not. Okay, great, it's working. Let's see if it loads. Okay, cool. So this was created by our Chief Protocol Officer, Ted Yin. As I mentioned, Ted was one of the creators of Hot Stuff, which is the classical consensus protocol behind Facebook's Libra or Diem network. And he's now at Ava Labs, I should say, working on Avalanche consensus. I'll play this again. I just wanted to explain what it's doing here. So real quick, the squares that you see at the top, you can think about those are different nodes in this little example network we have here. Each color of a node represents its current proposal. So we're trying to decide, is this transaction blue or orange, right? Avalanche consensus can handle non-binary decisions. It's worth mentioning, but for the sake of simplicity, helping you to develop an intuition around Avalanche consensus, in this particular case, it's a binary decision. Is this transaction orange or is it blue? The darkness of the color represents the node's conviction in that decision. So if it's a dark blue, that node really, really believes that this transaction is blue, obviously vice versa for orange. So when I press play here, each different node is going to start repeatedly, randomly sampling its peers, and it will then change its conviction and then the color of its it's going to change its decision whether it's orange or blue, and then the depth of that based on what its peers say. Hold on, let's try this one more time. So you can see that it only takes a couple rounds of repeated random subsampling, and the entire set will actually tip an avalanche into consensus. Let's see if we can play that one more time, because it's such a thing of beauty. So you can see it only takes a couple rounds of sampling, and the entire set will tip an avalanche into consensus. So I hope this gives you an intuition about how Avalanche consensus works. Technically speaking, Avalanche is a metastable consensus protocol inspired by epidemic protocols and gossip networks. And the process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling, which is what we just witnessed there. Okay, so that's Avalanche consensus. What about a network of networks? So in the previous paradigm, in so-called traditional blockchain networks like Bitcoin or Ethereum, you can think about there being a single blockchain or virtual machine and then one validator or miner set. So for example, think about Bitcoin. Bitcoin really runs one virtual machine, the Bitcoin virtual machine with script, the scripting language, and then it has the one single set of miners. Another example, of course, is Ethereum. The Ethereum network runs one virtual machine, the EVM, the Ethereum virtual machine, and then it has one set of miners. In this new paradigm, which is Avalanche, this blockchain 3.0 technology, we are a heterogeneous network of blockchains and validator sets. So heterogeneous means rich and diverse in character. So we are a network of networks, and there's compound network effects in Avalanche. So what does that mean? Many people have heard of network effects, but formally speaking, Metcalfe's law says that a network's value is proportional to the square of the number of nodes in the network. So for example, if a network has 10 nodes, its inherent value is 100, right? 10 times 10 equals 100. In other words, a product or service gains additional value as more people use it. And the canonical example, of course, is the telephone. If one person has a telephone, it's not that useful. If two people have a telephone, it's more useful. For every person who plugs into the telephone network, it becomes more valuable for every single other person because there's more people that they can call to leverage that network. Another great canonical example of the network effect is money. If only one person accepts a currency, it's not valuable at all, or it's not useful at all. The more people who accept that currency, it becomes more valuable for everybody else because there are more goods and services that you can use that money on. Now, compound network effects are sort of a level above network effects, and this is something that's called Reed's law. So Reed's law says that the utility of large networks, particularly social networks, can scale exponentially with the size of the network as the number of possible subgroups grows much more rapidly than either the number of participants or the number of possible pair connections. So even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. So Avalanche's subnets are really designed and primed for compound network effects. And here's a nice data visualization of this. I want to give a shout out to CryptoSec who created this, and you can kind of see there's the Avalanche ecosystem, and then each one of these circles represents a subnet, and then inside those subnets are green virtual machines, and then you're able to do cross-chain assets. So this gives you a sense of the heterogeneous network that is the Avalanche network. Next, we have virtual machines. So a virtual machine defines the application level logic of a blockchain. And in technical terms, a virtual machine is a state machine. It specifies the blockchain state, a state transition function, transactions, and then an API through which users can interact with the blockchain. And every blockchain on Avalanche is an instance of a virtual machine. One way to think about this is like object-oriented programming, if you're familiar with that concept. You can create a class, which is like a blueprint, and then you can instantiate the class into many different instances, which are objects. In our world, at the application level logic, the blueprint is a virtual machine. An instance of the blueprint, an instance of the virtual machine is called a blockchain. And as a developer, when you write your virtual machine, you don't need to concern yourself with the lower level logic such as networking. You don't have to worry about consensus. You don't have to worry about the structure of your blockchain. Avalanche does all of this behind the scenes so you can focus on what you want to build and the special sauce for your virtual machine. So why virtual machines? Um, at first, blockchain networks had one virtual machine. As I mentioned, like Ethereum runs the Ethereum virtual machine with a predefined static set of functionality. And this is a rigid and monolithic design that limits what blockchain-based applications you can run on such a network. And so again, people who wanted custom decentralized apps had to create their own, and entirely new blockchain networks had to be built from scratch. And doing this requires a great deal of time and effort. It offers limited security, and generally it just resulted in a very bespoke, fragile environment where none of these blockchains were able to ultimately get the network effects required to tip and go mainstream. Ethereum made a huge leap forward by solving this problem with smart contracts. So developers didn't need to worry about networking and consensus, but creating decentralized apps is still hard. The Ethereum virtual machine has low performance and it imposes restrictions on smart contract developers. So, for example, Solidity and the other languages such as Viper for writing Ethereum smart contracts are unfamiliar to most programmers. So, think about it. You use Golang all day, or Rust, or TypeScript, or Python, or C++, or whatever. But in this one specific domain, writing smart contracts, you have to switch over to Solidity. And it's not incredibly expressive. It's just not something you're used to working with all day. Avalanche virtual machines actually make it easy to define a blockchain-based decentralized app. And rather than these new limited languages such as Solidity and Viper, developers can write virtual machines in Golang or actually any language which supports gRPC. I'll talk about it here a little bit later, but we have a gRPC API. And if you have a language which can implement an interface to this gRPC API, you can write your virtual machine in that. And then lastly, we have subnets or subnetworks. So a subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. And each blockchain is validated by exactly one subnet, and a subnet can validate many blockchains. And a node can be a member of many different subnets. So let me walk that out a little bit again. Let me give you the visualization here about the whole system. So a virtual machine is the application level logic of your blockchain. A virtual machine can be instantiated into a blockchain. One virtual machine can be instantiated into many different instances. One blockchain is validated by exactly one subnet. One subnet can validate many different blockchains, including many different instances of the same virtual machine. One validator can belong to many different subnets, validating many different blockchains, including many instances of the same virtual machine across different public and private subnets. So if you were able to follow that out, you can get a sense of why we say the network is very heterogeneous, right? It's very rich and diverse in character. And some other cool things about subnets can manage their own membership, and they can require that constituent validators have certain properties, which we'll discuss here in a second. So a couple other cool points about subnets. There's compliance. So Avalanche's subnet architecture makes regulatory compliance very manageable, and a subnet can require validators to meet certain requirements. So for example, you can say, validators in my subnet all have to be located within a certain legal jurisdiction or a certain country. All the validators in my subnet have to meet certain KYC AML requirements. All the validators in my subnet have to hold a certain license. All the validators in my subnet have to have certain hardware requirements. Another cool thing about subnets is we have the support for private blockchains. So you can create a subnet where only certain predefined validators may join, and create a private subnet where the contents of the blockchain would only be visible to those validators. And this is obviously ideal for organizations interested in keeping their information private. So this is a regulatory compliance play. There's also the separation of concerns. In a heterogeneous network of blockchains, some validators will simply not want to validate certain blockchains because they simply have no interest in those blockchains. So the subnet model allows validators to only concern themselves with blockchains that they care about. And this reduces the burden on validators. And then lastly, you can have application-specific requirements. So different blockchain-based apps may require validators to have certain properties. So, for example, suppose there's an application that requires large amounts of RAM or CPU. A subnet can require that validators meet certain hardware requirements so that this particular application doesn't stutter or suffer from low performance due to slow validators. And when we went live with our mainnet last August, around 14 months or so ago, we launched what's called the default subnet or the primary subnet. This is what's live today. And on the default subnet, we have three blockchains. We have the X chain, which is an instance of the Avalanche Virtual Machine. It's a directed acyclic graph data structure, and it uses Avalanche consensus. We call it the X chain for exchanging assets. You can issue assets there. That's where AVAX was issued. AVAX is a fixed cap asset. There will only ever be 720 million AVAX. You can do variable or fixed cap assets, and you can also do non-fungible tokens. We have what's called the P chain, which is a linear blockchain. So it uses snowman consensus. It has total ordering. And this is where you do administrative tasks such as creating new validators, adding new delegators, creating subnets, instantiating virtual machines as blockchains on those subnets, etc. And then we also have the C chain, which is the smart contract chain, and it's an instance of the Ethereum virtual machine. So it also is a linear blockchain with total ordering, and it uses snowman consensus. And it has 100% backwards compatibility with existing EVM dev tooling and workflows. So if you have a dApp somewhere on another EVM, Polygon or Binance or Ethereum, you're suffering from high fees, you can just add a new network ID to your existing workflow with Remix or Truffle or Hardhat or MetaMask or whatever, and you can just deploy your contracts to our chain. And having 100% backwards compatibility, as you might imagine, really helped our network blow up over the last year and a half as the fees on Ethereum have risen so high, and because we're able to get extremely high throughput and incredibly fast immutable finality. So this is the default subnet. You can imagine launching your own subnet that looks similar in nature to this, but it could have your own blockchains. In addition to these, you can launch your own instance of the AVM or the EVM on your own subnet. This is live today. It's been live for over a year. So now I want to talk about cryptographic primitives. Avalanche uses a variety of cryptographic primitives for its different functions. And we'll briefly summarize the type and kind of cryptography used at both the networking and the blockchain layers. So Avalanche uses transport layer security at the network layer, TLS, to protect node-to-node communications from eavesdroppers. And TLS combines the practicality of public key cryptography with the efficiency of symmetric key cryptography. This has resulted in TLS becoming the standard for internet communication. And whereas most classical consensus protocols employ public key cryptography to prove receipt of messages to third parties, the novel Snow family of consensus does not require such proofs. So that enables Avalanche to employ TLS in authenticating stakers, and it eliminates the need for costly public key cryptography for signing network messages. TLS certificates. Avalanche does not rely on any centralized third parties, and in particular, Avalanche does not use certificates issued by third-party authenticators. All certificates used within the network layer to identify endpoints are self-signed, and this creates a self-sovereign identity layer No third parties are ever involved. Regarding TLS addresses, to avoid posting the full TLS certificate onto our platform chain, onto our P chain, the certificate is first hashed. So for consistency, we employ the same hashing mechanism for the TLS certs as what is used in Bitcoin. So namely, the DER representation of the cert is hashed with SHA-256, and the result is then hashed with RIPE-MD160. And this, of course, gives us a 20-byte identifier for stakers. And this 20-byte identifier is represented by the string node ID dash followed by the data's CB58 encoding string. And CB58 is basically like base 58 check. If you're familiar with that from Bitcoin, it's slightly different. We use a different checksum, but you can think of it as basically a base 58 encoding with a checksum. So you'll see CB58 many times in our documentation. It's a base 58 check, and it's a base 58 encoding with a checksum. So Avalanche, I'm sorry, cryptography on the primary network and the Avalanche virtual machine. Um, the Avalanche virtual machine uses elliptic curve cryptography, so specifically SecP256K1 curves on ECDSA key pairs for its signature on the blockchain. And this 32-byte identifier is represented by the string private key dash followed by the data's CB58 encoded string. And we have SecP256K1 addresses. Avalanche is not prescriptive about addressing schemes. Instead, we leave addressing up to each blockchain. And the addressing scheme of the X chain and the P chain rely on SecP256K1. Avalanche follows a similar approach to Bitcoin and hashes the ECDSA key, public key. The 33-byte compressed representation of the public key is hashed with SHA-256 once. The result is then hashed with RIPE-MD160 again to give us a 20-byte address. And then Avalanche uses the convention of chain ID dash address to specify which chain an address exists on. We also have BEC32 addresses. We're big fans of BEC32. We use them on the X chain and the P chain. Some benefits of BEC32 include it's base 32 encoded instead of base 58. It's character insensitive. It's easier to compute. There's no big num operations. It has superior checksums for prime power. It's actually 17% larger than base 58 check, but it's smaller when you encode it as a QR. And then it's in use, BEC32 is in use in systems today, such as Bitcoin BTC, Tor, I2P, other networks, and then, of course, the Avalanche network. And then we have 65-byte SecP256K1 recoverable signatures. So now I want to cover some stats and highlights from our amazing ecosystem because we've just seen so much cool stuff happen over the last 14 months. So regarding staking, as of this morning, I gathered these stats this morning. The Avalanche network has 1,092 full block and vertex producing validators, over 16,000 delegators, and over 247 million AVAX staked, which is currently $17.749 billion. So that's what's staked. But on our C chain, we've seen an explosion in growth. Check out these charts. So the Avalanche C chain recently saw an all-time high of 422,635 transactions in one day on October 22nd. You can see that in that top left red chart. We also recently crossed 500,000 cumulative addresses. We've had over 17 million total transactions, and we're about to cross, I'm sure it'll happen today, 30,000 deployed smart contracts. And we have at the bottom, you can see 13.8, nearly $14 billion in total value locked on our C chain. So not only do we have $17.7 billion staked on the whole network, we also have $14 billion in total value locked. So as you can see and this is just, a small handful of graphs. All of the graphs are looking like this. We've had absolutely explosive growth. To give you a sense of what's happening in our ecosystem, since we launched our mainnet in August of 2020, we've seen just an absolute explosion across our entire ecosystem, especially around DeFi. So as I mentioned, we have 100% backwards compatibility with existing EVM dev tooling. So it's relatively straightforward for teams to add a new network ID to their workflow and just deploy their smart contracts to the Avalanche network. And I want to highlight some things you can do on our network. I'm sure that I will miss some teams. If you're watching this and I didn't mention your team, I did not mention your team. I promise I don't mean any insult. I'm just grabbing a handful of these to highlight. So of course we have dexes. You can trade on a dex. We have Trader Joe, which is a clone or a fork of SushiSwap. We have Pangolin, which was created by the amazing Connor Daly from our team. That is a fork of Uniswap. We have Paraswap, which aggregates decentralized exchanges into one comprehensive interface. And then, of course, we have SushiSwap. SushiSwap has recently come over to the Avalanche network thanks to the Avalanche Rush program, which we're going to briefly discuss here in a second. You can use a yield optimizer. So, of course, we have YieldYak, which we have Snowball, which combines multiple DeFi protocols. And then we have Yield. Yield is a licensed fintech company that enables anyone to invest in DeFi. You can, of course, manage your portfolio. So we have Marker. That's where I got some of these statistics. It's a portfolio management and tracker tool. We have DBank, which is a DeFi wallet for managing and tracking your DeFi portfolio. And then we have ApeBoard, which is a cross-chain DeFi dashboard. I like their tagline, built by apes for apes. That's pretty cool. You can borrow or lend. We have Banky. Banky is a compound clone. Within 4 days, they had $1 billion in total value locked. It's a non-custodial algorithmic liquidity market protocol. We have Aave. Aave just recently came over through the Avalanche Rush program. We also have Curve. Curve also recently came over through the Avalanche Rush program. Avalanche Rush is a program, an incentivization program to get the blue chip dApps to come into the Avalanche ecosystem from other EVM ecosystems, most notably Ethereum, and we've had a ton of success there. And then, of course, we have lots of NFT marketplaces. We believe that Avalanche has the potential to be the premier platform for launching licensed NFTs. And with that in mind, our team, in concert with the TOPS team, recently launched an NFT marketplace. We went out live initially with Bazooka Joe, but since then, MLB has launched, Bundesliga has launched. I think about a week and a half ago, right before I came to Lisbon, Godzilla launched. And then there's a lot more on our roadmap. So that's very exciting. But as you can see, we have others like Curate. We have Flashback, which is a ticketing experience. It bridges art, events, and organizers and people. We have NFT Stars, which is a multi-chain NFT marketplace. We have Polyant Games, which is NFT-focused decks. Chivas, which is Mexico's most popular soccer club, recently celebrated their 115th anniversary by launching an NFT on Avalanche. That was very exciting. Recently, an artist auctioned off a piece of artwork around Kanye West, that a Kanye West mural that recently got sold last week. That was incredibly successful. So, as you might imagine, we have a booming NFT ecosystem as well. And so now I wanted to talk about Avalanche Rush. Back in August, the Avalanche Foundation announced Avalanche Rush, and at the time, this was a $180 million liquidity mining incentive program. Since then, the price of AVAX has increased. So as of this week, I believe it's around 600 million. As I mentioned, it's a liquidity mining incentive program to introduce more applications and assets to Avalanche's growing DeFi ecosystem. And just real quick, I'll talk about if you're interested in this. There is an application process. You can check out our docs, and you can actually connect with our DeFi team, led by the director of DeFi, Luigi, who's an absolute block star. And you can see if it makes sense to somehow get your team or your dApp involved in the Avalanche Rush program. Just some of the examples of what we've got going on. Aave has a $20 million incentives coming soon. Banky has $3 million. SushiSwap has $7.5 million in AVAX incentives. Curve has $7 million in incentives. Pangolin has $2 million. Trader Joe has 20 million. So there's 10 million in AVAX and then 10 million in Joe. Okay, so now I wanted to, the last part of the presentation, I believe I still have 16 minutes or so, so this should be good. I wanted to now talk about subnets and virtual machines. So as I mentioned, a subnet is a set of validators working together to come into agreement on the state of a set of blockchains. And again, each blockchain is validated by exactly one subnet, which is specified when you create the blockchain. And subnets are a very, very powerful primitive that allows the creation of completely permissioned all the way to completely permissionless networks. So if you're launching the next Bitcoin or the next Ethereum, the next totally permissionless network, you should launch it as a subnet on Avalanche. You get so many things out of the box. Also, if you're launching a completely permissioned network in the context of regulatory compliance, you should also do that on Avalanche because, as I mentioned, we have this full spectrum of permission to permissionless networks built into this subnet API. So to give you a sense of how this works, when a subnet is created, a threshold and a set of keys are specified. And in order to add a validator to that subnet, threshold signatures from those keys are needed. And we call these the subnet's control keys. And we call a control key signature on a transaction that adds a validator to a subnet a control signature. So basically, the super high level of this is that a subnet has complete control over its membership. So what does it look like to create a subnet? The steps for creating a subnet are as follows. So first, you need to generate the control keys. You can do this using the Avalanche Go client or Avalanche JS. For what it's worth, we consider it an anti-pattern to create and manage keys on the full node, and we suggest that you generate keys and sign all transactions locally using something like Avalanche JS. So now you need to create the subnet. You can use the platform.create subnet RPC call on the Avalanche Go full node, or you can use the create subnet transaction serialization using Avalanche JS. And you'll need to pass in an array of addresses and a threshold. So for example, let's imagine you pass in 3 addresses and a threshold of the number 2. This basically configures the threshold control signature that you need to submit to make changes to the subnet. And this includes adding validators and launching virtual machines as blockchains. You can verify the success by calling the platform.getSubnets RPC, and you can confirm that the subnet was successfully created. And then you can add subnet validators. So you can add subnet validators with the platform.addSubnetValidators RPC call, or you can use the add subnet validator transaction serialization with Avalanche JS. And you'll need to pass in the following parameters when you do this. The first is you have to pass in a node ID, and this is the node ID of the validator that's being added to the subnet. And this validator must also validate the primary network for the entire duration that it validates the subnet. Next, you need to pass in the subnet ID. This is the ID of the subnet that we're adding a validator to. You also need to pass in the start time and the end time. And these are Unix timestamps that the validator will start and stop validating the subnet. So start time must be at or after the time that the validator starts validating the primary network, and end time must be at or before the time that the validator stops validating the primary network. And then lastly, you need to pass in the weight of the validator. And this is the validator's sampling weight, which is used for consensus. If the validator's weight is 1, for example, and the cumulative weight of all validators on the subnet is 100, then the validator will be included in about 1 out of every 100 samples during consensus. And the cumulative weight of all validators in the subnet must be at least the value which is passed into the snow sample size flag. So this is a flag you can pass in whenever you fire up your Avalanche Go network. So for example, if there is only 1 validator in this subnet, its weight must be at least 20, which is the default value for snow sample size. A validator's weight cannot be changed while it is validating, so you want to make sure to take care and use an appropriate value when you add a validator to your subnet. And to confirm it was successful, you can call platform.getPendingValidators or platform.getCurrentValidators. Those are RPC endpoints. You can actually pass in a subnet ID, and you can get pending or the current validators and delegators of any subnet you wish. You can also do private subnets. So Avalanche's subnets are public. It means that every node can sync and listen to ongoing transactions and blocks in a subnet, even if they're not validating that particular subnet. So subnet validators can choose not to publish the contents of the blockchains via an optional validator-only configuration. And this configuration can be turned on in the subnet configs. And if a node sets validator only to true, the node exchanges messages only with this subnet's validators. And so other peers will not be able to learn the contents of this subnet from this node. but it's worth noting that this is a node-specific configuration, and each validator of this subnet has to use this configuration in order to create a fully private subnet, which is what you would want to do for regulatory compliance, for example. You also have to whitelist the subnet. So now that the node has been added as a validator on the subnet, you actually have to whitelist it. And this whitelist prevents the node from validating a subnet intentionally. For example, you wouldn't want me to be able to create my own subnet and add your node as a validator. So to whitelist the subnet, you have to restart your node and you have to add the flag whitelisted-subnets, which is a comma-separated list of subnets to whitelist. And then lastly, I want to talk about virtual machines. So as I mentioned before, a virtual machine is the application level logic of your blockchain, and a blockchain can run as a separate process from the Avalanche Go process and can communicate with Avalanche Go over gRPC. So this is enabled by the RPC chain VM, which is a special VM that uses Go plugin and wraps another virtual implementation. So for example, the C chain runs the core ETH virtual machine in this particular fashion. And so a couple things about virtual machines. A virtual machine must implement a particular interface to be compatible with Avalanche's Go consensus engine to reach consensus on linear blockchains as opposed to DAG blockchains. So there's two types of blockchains. You can have a directed acyclic graph, which has partial ordering and uses Avalanche consensus. And we have linear blockchains, which have total ordering and use Snowman consensus. To reach consensus on linear blockchains, Avalanche uses the Snowman consensus engine. And in order to be compatible with Snowman, a VM must implement the block.chain VM interface. And chain VM defines the functionality required of a Snowman virtual machine. So a Snowman virtual machine is responsible for defining the representation of state, the representation of operations on that state, the application of operations on that state, and the creation of the operations. So consensus will decide on if the operation is executed and the order operations are executed in. So for example, suppose we have a virtual machine that tracks an increasing number that is agreed upon by the network. The state would be a single number. The operation is setting that number to a new larger number. Applying the operation will save the database the new value, and the VM can attempt to issue a new number of any larger value at any time, and consensus will ensure the network agrees on the number at every block height. So we have a couple helper libraries. We've created some types that your VM implementation can embed. Embedding is like Go's version of inheritance. So we've created some types that your VM implementation can embed in order to handle boilerplate code. We have core.snowman VM. This helper type is a struct that implements many of the block.chain VM methods. We have core.block. This helper type implements many methods of the snowman.block interface. We have RPC chain VM, which is a special virtual machine that wraps a block.chain VM and allows the wrapped blockchain to run in its own separate process apart from Avalanche Go. An RPC chain VM has two important parts. It's got a server and a client. The server runs the underlying block.chain VM in its own process and allows the underlying VM's methods to be called via gRPC. So the client runs as part of the Avalanche Go process and makes gRPC calls to the corresponding server in order to update and query the state of the blockchain. So some example VMs are the Ethereum virtual machine, the EVM, the Avalanche virtual machine, the AVM, the platform VM. There's work on a Bitcoin virtual machine happening right now. You can imagine a WASM VM. You can imagine recursively snarked virtual machines like Mina or Cairo. We have what's known as the timestamp VM, which allows you to take the hash of a document and add it with a timestamp to a block so that later, if you needed to prove you owned the IP of a document, for example, you could take a hash of that same document and show that it had been written to a block at a certain time, that kind of thing. And then recently, we just released Ava Sim, which is a new custom VM simulator where you can run a custom VM with one single command. And this makes it easy for anyone to spin up a local instance of an Avalanche network to interact with, the standard APIs, or a custom VM. Okay, so there was a lot there. In summary, Avalanche is a global financial network for the issuing and trading of all digital goods, and we're calling it the Internet of Finance. And we consider Avalanche to be blockchain 3.0 technology with new paradigms of Avalanche consensus. Avalanche is a network of networks. We have subnets or subnetworks, which are dynamic sets of validators working together to achieve consensus on the state of a set of blockchains. And lastly, we have virtual machines, which are simply the application level logic of your blockchain. So thank you so much. My name is Gabriel Cardona. I'm developer evangelist at Ava Labs. I want to express gratitude to the Chainlink folks. Thank you guys for having me. Of course, I want to express gratitude to the Ava Labs team. Thank you so much. It's an honor to work with you, ladies and gentlemen, each day. You can find me at CG Cardona on Twitter or Telegram. Feel free to reach out to me. It's my job and my honor to on-ramp amazing people into this ecosystem. So I try and get back to everybody who reaches out to me. I get a ton of inbound messages. So if it takes me a little bit to get back to you, don't worry about it. I do intend to do that eventually. So that's it. Thank you so much.